This is 100 Sudokus being solved at the same time. And in this video, I will attempt to solve 10 million Sudokus. I'll try to create the world's longest Sudoku, which is pretty much the height of a building. And finally, I will attempt to create the world's hardest Sudoku, which is this beast right here. It's 20,000 pixels by 20,000 pixels, and it has close to 5,000 interconnected Sudokus with a little twist to it. But before all that, a brief 10-second history lesson. The Sudoku was basically invented by these two awesome dudes. You play by placing numbers 1 to 9 in each row, column, and 3 by 3 grid without repeats. They give you some starting numbers and you have to complete the whole thing. And I suck at it. Seriously, like, I'm not very good. Luckily, we have computers. And instead of teaching myself how to complete one in a couple of hours, I'm gonna spend the 3 next weeks of my life teaching my computer to do it. So, there are tons of ways to solve a Sudoku with code, but in this video I'm going to use a recursive backtracker. It's basically brute forcing the puzzle, but I think it's pretty awesome. I also used it in my maze video and it gave me some pretty cool results. So, I tried building a Sudoku solver using backtracking on LeetCode. I got some interesting bugs, but eventually I solved it. And here's how backtracking works. You start at the beginning of the Sudoku and start guessing random numbers. And of course, you gotta check that the number is not already in its row, column, or 3 by 3 grid. But let's say everything is okay. We then kind of assume that our guess is correct and move on to the next. You keep doing this until you realize, uh-oh, something is not right. And that means one of our previous guesses has to be wrong. So then you backtrack or go back to your previous guess and try a different guess. And if you actually keep doing this, you'll eventually solve the Sudoku, which is pretty sick. Even if your very first guess is wrong, you can backtrack all the way there, change your guess, and still solve the Sudoku. And check this out, look at this Sudoku over here, boom, it's solved. Oh no, a wild Sudoku has appeared. Backtracking to the rescue, boom, solved. Now I want to test out my shiny new Christmas toy against some Sudokus. And I want a lot of Sudokus. 10 million to be exact. So I went on the hunt for fresh new Sudokus, and turns out there's a ton of Sudokus out there on the internet. I found this Kaggle dataset with 9 million Sudokus. I did some calculations and voila, we have 10 million Sudokus. And just so you get a feel for how big this is, the CSV file that I downloaded, which is basically a glorified text file, weighs 1.5 gigabytes. Which, yeah, it's not great for my Mac storage, but it's really good news for my hungry recursive backtracker. Cool, let's solve 1000 Sudokus to get started. Whoa, look at it go. That literally took 2 seconds. That's pretty cool. Let's try 10,000. Okay, that was a bit slower. Now, if we do some quick math, that means that it will take about 8 hours to solve all 10 million Sudokus, which is unacceptable. We need more speed. So I manually translated all my Python to C++, and this was the moment I tried it. Okay, let's see what this thing can do. Okay, let's compile. And let's go. That took like 2 minutes for 10 million. Like honestly, like C++ is a beast. So yeah, Python would have taken 8 hours and C++ did it in under 2 minutes. Alright, that's 10 million Sudoku solved. That's pretty cool. Now I want to solve something even more challenging. So I did a bit of research and I stumbled upon this, the world's longest Sudoku. This guy, Frank Longo, published a book in 2006 with 167 connected Sudokus. It's really long and it takes up like a whole room. And I thought, that's pretty cool, I'll make my own. And here's where we enter the beautiful world of Sudoku generation. And it's not as easy as you might think. You see, a Sudoku always needs to have a unique solution, which complicates things. At first, I had no idea how to do this, so I read this 2009 paper called Sudoku Puzzles Generating from Easy to Evil. It's a really detailed paper which pretty much gives you the recipe to cook up some fresh Sudokus. So to make your own Sudoku, you will need the following ingredients: a bit of C++, a 9x9 grid, and a bit of luck. Alright, first things first, what you do is you take an empty 9x9 grid and sprinkle in some random numbers. And this is actually pretty important because it gives our Sudoku a bit of randomness. In the paper, they actually calculate that the ideal amount of random numbers to sprinkle in is 11. So we'll do that. Cool, next step is to generate a solution for the Sudoku. So we take our trusty old recursive backtracker and boom, we generated a random solution. Nice, now we have a perfect, beautiful Sudoku. However, we need to make it challenging. We need to remove some numbers, also known as digging holes. And here's the interesting part, you can't just remove any number, because sometimes this might change the way you solve the Sudoku, leading to multiple solutions. We don't want that, so we gotta make sure that every time we dig a hole, the solution is still the same. And one way to do that is to try replacing that number with each of the other possible digits and ensure none of these changes or creates another valid solution. In other words, we have to call the recursive backtracker 8 times and check that it cannot solve the Sudoku with the changed number. And if we do this for every number, ta-da, we generated a Sudoku. Hopefully that wasn't too boring. Cool, now for the fun part, creating the world's longest Sudoku. So after a bit of C++ magic, I implemented the Sudoku generation algorithm and I generated 500 Sudokus. And here was the tricky part. The solution of this part of the Sudoku has to match the next Sudoku, and so on and so on. This was really tricky, so I'll spare you the details. Just know there was a lot of bugs. But finally, here you go, the world's longest Sudoku. It has 500 chain Sudokus, and to solve it, you start by the very first one and you don't stop until you reach the end. I did some calculations, and if each Sudoku was 3 feet by 3 feet, it would be almost as tall as the Empire State Building. Now, it's definitely not the biggest, but I looked on the internet and there doesn't seem to be a Sudoku longer than this, so I'm claiming this title, at least for now. Alright, cool, now we can pretty much solve any number of Sudokus we want, but there's a slight problem. Take a look at this Sudoku. What do you think would happen if we tried to solve it? Well, let's find out. And while my little backtracker is hard at work solving this, I'm gonna quickly tell you about Brilliant. And you might want to pay attention because they're pretty awesome. Brilliant is an online learning platform for science, computer science, and math, and their whole goal is to make learning hard things fun and simple. They give you hands-on exercises on everything from linear algebra to computer science. Instead of just reading or memorizing formulas, they let you play with code and maths, which is pretty much the best way to learn something. They have really good courses on computational thinking all the way up to neural networks. In fact, they have a course on programming with Python, which is my favorite programming language and the one I have been using for most of this video. Brilliant is a great way to get started with coding and learn something new if you already have experience. So, if you want to support this channel and learn some pretty fun things, click the link in the description and use my code GREENCODE for a 30-day free trial and a 20% discount on the annual premium subscription. Alright, cool, we finally solved this Sudoku, but it took a really long time. Python took this long and C++ took this long. Turns out, this Sudoku was specifically designed against a recursive backtracker. This is because the solution to the first line of the Sudoku is 987654321. So the algorithm will take ages counting up until it reaches the right solution. Okay, so if this is hard for a computer, is it also for humans? Turns out, not so much. For us mere humans, the difficulty of a Sudoku depends on the techniques used to solve it. For example, these are all pretty easy techniques. So if you can solve a Sudoku using this, then we rate that Sudoku as easy. However, if we need to use more advanced techniques, then the Sudoku is rated as harder. And this is gonna come in handy because my final goal for this video is to build the world's hardest Sudoku. So the first thing I did was to generate about 6,000 Sudokus and rate them. As you can see, most of them were easy, but more than 40% were hard or even extremely hard, which means my algorithm is not bad at generating hard puzzles. I also want to point out this category over here. Some Sudokus were so hard that my grader threw like an error. I had to check them with a different website and I got a grade of diabolical. This diabolical Sudoku right here was the highest score I've seen from the ones I've checked. Now, since I want to generate the world's hardest Sudoku, I need a new pattern because this isn't gonna cut it anymore. And after loads and loads of bugs and perhaps the worst code I've ever written, seriously, like, it's bad. I'm pixelating it, I don't even want to show you. But I finally got this. It starts from a central Sudoku and it tries to minimize the amount of common sub-boxes between Sudokus. So for example, all these Sudokus are not connected. after a bit more work on the visualization part of things, I managed to generate this, which honestly, I think it looks super sick. Like, the amount of effort this took me to code is crazy. And finally, I wrote this little function over here that keeps generating Sudokus until a hard one is generated. So only hard and extremely hard puzzles will be included in the final Sudoku. I left my computer running through the night and I woke up to this. Are you ready? This is the world's hardest and biggest Sudoku. It has 4,810 interconnected Sudokus. It's so big that its image is 20,000 by 20,000 pixels. It's so big that my computer even struggles to open it. And every single one of these Sudokus is rated at least hard, with most of them being rated as very hard or extremely hard. And of course, the very central Sudoku, the one you have to complete first before moving on to the others, is a diabolical level Sudoku. And again, it's designed so that the Sudokus share as little subsquares as possible. I don't know how long it would take for someone to solve this manually, but let's just say it would take a really long time. I also generated the solution, so I guess if you actually solve it, let me know and I'll tell you if you did it right. All the code and the images will be uploaded to Patreon for you to enjoy, and that's pretty much it. Check out the Discord server and maybe subscribe if you want to. I hope you enjoyed, and I'll see you in the next one.